In this video, we're going to be looking at the second half of lesson 9.1 on areas of triangles and quadrilaterals. If you haven't already completed the 9.1 day 1 notes, you should do that first. In day 1, we looked at how to find the area of rectangles, parallelograms, triangles, and trapezoids. In day 2, we're going to focus on 2 more special quadrilaterals, and those are rhombuses and kites. So you calculate the area of a rhombus or kite using the formula area equals 1/2 d1 times d2, where d1 and d2 are the lengths of the full diagonals. So if the diagonals are divided into sections, you'll need to add the sections to find the lengths of the full diagonals. And we'll look at an example like that in just a moment. Another way that you can write the formula for the area of a rhombus or kite is instead of the half, you can just do area equals d1 times d2, and then divide that result by 2. Dividing by 2 is the same as multiplying by a half. So in our picture here, the first shape is a rhombus, and the lengths of the diagonals, d1 would be all the way across, and d2 is all the way across the other way. Similarly, in the kite, d1 is one of the full diagonals, and d2 is the other. So now that we have our formulas down, let's go ahead and look at a couple examples involving finding measurements of rhombuses and kites. The first thing we're going to do is calculate the area of this kite. And to calculate the area, we can use that formula that we just wrote down, area equals 1/2 d1 times d2. Here, though, we need to do some calculating before we figure out the calculation. D1 is one of the diagonals. It doesn't matter which one's D1 and which one's D2. So D1, I'm going to let be the 12 plus the 12. So D1 is 24. Then we'll do the same to calculate D2. So D2 is that second diagonal. And notice how that is 20 and 12. So I need to take 20 and add 12, and that's 32. So those values there, the total lengths, are what we need to use for the diagonals. So now let's go ahead and substitute those values into our formula. Area equals 1/2. D1 was 24, and D2 was 32. And if you go ahead and calculate that, 1/2 times 24 times 32 ends up being 384. And when you're typing this in your calculator, it's fine to change the half to 0.5. Or remember, if you want to, you could also do 24 times 32 first, and then get a number for that, and then divide it by 2, and you'll get the same answer in the end. Let's make sure, though, that our final answer includes the appropriate unit. Since there's no unit given in this problem, we can just say units squared. Doesn't tell us it's inches or centimeters or anything. So we'll say units squared, or U squared for short. Let's try another example. For part B, we have a kite that has an area of 48 square centimeters, and the length of one diagonal is 16 centimeters. Find the length of the second diagonal. We still want to use the area formula for a kite, which is 1/2 d1 times d2. So this time, we know the area is 48. So I'm going to substitute 48 right here. And then D1 is the 16. And D2 is our unknown. When you're multiplying, you can just kind of go in whatever order you want. So since I have the 1/2 and the 16, let's just start by multiplying those together. They make 8. So 8 times D2 has to equal 48. Well, now if we just divide by 8, that gives us D2 equals 6. So the length of the second diagonal is 6 centimeters. So these two examples have both been kites. In the next example, we're going to look at a rhombus. Remember that rhombuses and kites have the exact same area formula. Area equals 1/2 D1 times D2. In this last problem here, we're given the perimeter of a rhombus is, and that should actually say 52 centimeters. So I need you to change that. So the perimeter of the rhombus is 52 centimeters, and the length of one diagonal is 10 centimeters. So let's go ahead and start by figuring out what the sides are. Remember some properties of rhombuses. In a rhombus, all sides are congruent. So if the perimeter here is 52, take 52 and divide that by 4, since there are 4 sides, and that's 13. So each of the sides in our rhombus is 13. Then we can also add in that one diagonal is 10 centimeters. I'll let that be D1. And then the other diagonal that I'm trying to find will be D2. Now, diagonal 1, I'm just going to pick this piece right here, BD, to be diagonal 1. If the diagonal is 10, remember that a rhombus is a parallelogram. So in a parallelogram, the diagonals bisect each other. So that means that it's cut in half. So this half and this half are going to be the same, right? So if the diagonal 1 is 10, let's take half of that 10, divide it by 2, and we get these sides as 5. Now, another property that you learned about rhombuses in our last unit is that the diagonals are perpendicular. And perpendicular just means that they intersect to form 90-degree angles. So what I really have here is I have 4 right triangles. All of these are going to be right angles. Let's just look in at one of the triangles. So I'm going to focus in on this one right here that I'm coloring with my yellow highlighter. Now, since that is a right triangle, we can go ahead and calculate the missing side by using the Pythagorean theorem. So we have a squared plus b squared equals c squared, and c has to be the hypotenuse. So the c has to be the 13. A and b are the other two sides. I'm going to let this side be x. So I'll go 5 squared plus x squared equals 13 squared. And now we just do our Pythagorean theorem. 5 squared is 25. 13 squared is 169. Let's subtract 25 from each side. To get x squared equals 144. To find x, we need to undo the squared, and we undo a squared with a square root. So we'll square root each side, and that gives us x equals 12. Now, if this is 12, remember the diagonals bisect each other, so these two diagonals are also equal halves. So these are all 12. So I have kind of 4 triangles that are 5, 12, and 13. So how does that help us find the diagonal? Well, look at the second diagonal, diagonal 2. It's those two 12s put together. So 12 plus 12 is 24. So the second diagonal is just 24 centimeters. And now that we have that, we'll be able to find the area of the rhombus, because the area of a rhombus is the same formula as the area of a kite, d1 times d2 divided by 2, or 1/2 d1 d2. d1 and d2 are given, so d1 was the one I started with, 10, and d2 we calculated as 24. So we need to do 10 times 24, simplify the top first, that's 240, and then divide the result by 2, and when you do that, you'll get 120. So the area of our rhombus is going to be 120 centimeters squared, and that is our final answer. And that's it for this video. In day 1, we looked at how to find the areas of parallelograms, rectangles, triangles, and trapezoids. And now in the day 2 video, we just saw how to find the areas of rhombuses and kites. You're now ready to complete your 9.1 CYU assignment. Thanks for watching, and good luck as you practice some areas on your own. Bye.